Hello everyone and welcome back. A big part of being a professional developer is knowing how to write automated unit tests. And in this section, you're going to learn exactly how to do that. We're going to start off by looking at what unit tests are and what makes them so valuable. You'll then learn how to add unit tests to an existing project. We'll then dive in and look at some really good examples of what makes a good unit test and what doesn't. And then finally, you're going to learn how to write some really good testable code. But let's start with a simple explanation of what a unit test is and how they work. Unit tests are small method-level tests developers write to prove to themselves that their code is actually working. Here's a simple example. Here we have a simple structure, a user view model, and we can test or validate our logic inside the view model by writing an automated test. For example, here we could instantiate the user view model, pass in some users, and then verify that when we call the hasUsersComputed property, this returns true. We can run a unit test like this by clicking on the green arrow on the left. And if all goes well, that test will run, we'll get back some positive feedback, and voila, we've proven to ourselves that our code actually works. Now, don't let the simplicity of this test fool you. We can actually test some really complex logic and get into some really hard places in code all through unit tests. And the advantages that come with doing this are numerous. For one, they give you instant feedback. When you make changes to your code and a unit test breaks, you know about that instantly, not 3 weeks later after you've rolled into production. Second, unit tests dramatically lower the cost of regression testing. Instead of having to retest everything every time we pump out a new release, we can save ourselves a lot of time and money by automating this really easy stuff so that we've got more time to test the complicated stuff. Thirdly, they greatly reduce debugging time. When a unit test fails, you know exactly where the problem is. No more firing up the debugger and stepping through the thousands of lines of code searching for that offending piece of code. Unit tests cut through the fog like a laser and show you exactly where your problem is. And fourthly, they let you deploy with confidence. It just feels good rolling into production knowing you have a suite of automated tests backing you up. They're not foolproof, but they can free you up to test the more interesting, complicated parts of your system and not retest the really, really simple stuff. If it helps, think of unit tests like this. Unit tests can be your armor that you don before riding into battle. They become a form of executable spec that lives forever in your code, and they protect you from missiles, real and imaginary dragons, and most importantly, ourselves. So let's jump back now to the Weatherly app and see what unit tests we could write there to improve the overall quality of our code. Okay, so before we can actually add any unit tests to our project, we first need to configure our project to run unit tests. And if this was a brand new project, that would be really easy. We'd simply go in, select app, and then include this little check mark down here called include unit tests. So then if we created our project, something with a name like this, and saved it, our project would be configured and good to go with unit tests already added. Of course, we don't have that, so we're going to have to add our unit tests manually. Let me show you how to do that to an existing project that doesn't already have unit tests in there. Okay, so unit tests in Xcode run as their own target, which means we're going to have to add a new target to our project in order to run our unit tests. But fortunately, that's not too hard. We can do it just like this. If you click on your project name up here, you'll see the lists of targets we currently have. We just have one which currently runs our app, the Weatherly app. We're going to add a new one down here by clicking on the plus sign for add a target. And then in here, simply type the word unit, and you should see a unit testing bundle option appear. Click next, select that. Go ahead and select the default name that it gives you, or you can just call them unit tests if you like. Click finish, and those will then be added to a project, and you will now see a new target here representing our unit tests. Now we can open up our new target here. This is where we're going to write all of our tests, and they're kind enough to give us one out of the box. This is a standard default test that comes with any new test target. And in here you can see the basic anatomy of a unit test. All unit tests are classes that extend the XTC unit test case. This is a class we inherit from. They give us some routines. For example, this setup with error and teardown. Sometimes when we're writing unit tests, we want to run the same code for each test that's run to kind of give us a clean slate as we're running. We might make use of that later, but we don't really need it right now. Here's an example test where you could put your sample test code. The format here is to begin your test with the name test, followed by whatever it is you'd like to test. And this is a special kind of test down here. This is called a performance test. This isn't one I actually use very often, and I tend not to use it, but it could be used to measure the performance of your app and make sure your app's not going either too long or suffering from a big change that you might have recently made. Now what you and I are going to do is we're going to write a unit test for the JSON parsing that takes place in our weather service, specifically way down here where we parse the JSON. This is something that's a really good line to test because JSON parsing, things can go wrong. So if we can write a unit test that verifies we can bring some JSON in, parse it correctly using decodable, that would be a great unit test. Unfortunately, we've already got a playground which kind of sets us up really nicely for that. This is the parsing weather JSON playground. This is something we created just when we were initially testing our parsing. And here you can see some JSON that we want to parse in the app. Here you can see how we set up our decodables. These are the objects that decode the JSON. And when we run it down here, we verify that we can convert that JSON into a weather data object and finally pull the results out like this. So let's see if we can't write a unit test very similar to this and verify that we can indeed parse the incoming JSON. Okay, let's start by going over to our new test target here. Let's go Command N and let's add a new unit test case here. So this option was already selected for me. If it's not, just navigate to where you can see unit test case class, click next, and let's go ahead and give it a name. Usually we map our tests one-to-one with the classes that we're testing. In this case, because it's the weather data struct that we're testing, I'm going to go ahead and call this weather data test and just leave all these options here. These are all fine. We'll click next and we'll accept wherever it wants to stick it for us, which is in our weather target here. And then you'll see a new class come down here, already set up and configured just like the ones we typically get when we create a new test project. Let's go ahead and just clear out most of what's in here. We're going to start with a clean slate. Let's get rid of all this. And you can see it's already set up for us to extend from test case. And in here, this is where we're going to write our test code to basically test and verify that we can do our JSON parsing. Now you may be wondering, what exactly here do we want to test? Things we typically like to test when unit testing are, first of all, the happy path or the expected results. So we're going to write a test in here that verifies we can indeed parse some incoming JSON. But other things that are also really good candidates for unit tests include things like edge cases, boundary conditions, basic logic in our app. You can think of it, you can test it, and that's really the spirit of unit testing. If you've got a question about your code, go ahead and write a test for it. Now, to be clear, the goal here isn't 100% test coverage. It's way better to have 10, 20, 30% test coverage covered by a really good suite of tests. So don't worry about testing everything. Just start with what's really obvious, and then any other questions you've got, we can add to the test. But let's start with the happy path, which for us is just going to be taking the JSON we decoded in our playground. And let's just see if we can take this and have it decode properly in our test. So we're going to start by, first of all, giving this a decent test name. And because we're just simply testing that we can parse the weather, why don't we call this test can parse weather. And in there, let's just drop in that string that we want to parse, just like this. So we're just going to embed the JSON right in here as a multi-line string literal. And down here, we're just going to add the code that actually does the parsing for us, which for us is just going to be this. Now I know what you're thinking. Hey, we've got a try in here, and aren't tries dangerous? This would really blow up our app. And you're absolutely right, it would. In unit tests, however, it's okay to be a little bit more aggressive and go ahead and use things like tries and bangs. If the test blows up, that's okay. We want to know right away. We want that feedback very quickly. So in this case, I'm going to go ahead and use the bang. Now you'll see it complaining here. It doesn't know what our weather data is. Or in other words, our weather data, which lives up here in the model, isn't in scope yet for the tests. So how do we fix that? Well, the first step would be to obviously just import our weatherly2 module like this and see if that makes that go away. And hopefully it will. I'll just do a Command B to give it a kick. And it does. But it's still complaining. It still can't find our weather data even though we're importing the project here. And the reason for that has to do with the scoping given to our target up here for our app. All of the classes you see defined up here in our main weatherly target, they have a default internal scope, which means they can be seen within this weather2 target. But we want to test it down here in a separate target where our unit tests live. So even though we've imported it, that's not sufficient for us to be able to run our tests. Fortunately, the good people of Apple have thought of this for us, and they've given us a way to take the internal scoping of our classes here and expand it something akin to almost being public. And what we can do is we can use this test attribute called testable, which will take these classes, expose them for us in our test target. So now we can come down here and actually use them in our test case. Okay, now comes the fun part. We've imported our JSON, we've run our code. Now we just want to make some tests to prove that it's working. And for us, we're going to be doing that with the xc assert command. This function, as you can see, has a whole bunch of different ways that we can actually assert things for whatever it is we're testing. We can assert true and just put expressions into that method to verify that things are true. We can check for nils, we can check for false, we can check for equal. And in our case, this equal is going to be really handy. What we'd like to do is verify that when we parse our JSON and get back our weather data, we can indeed pull out temp, which is the temperature we want here, and also our weather data name, which is the city that we're getting the weather for here. And of course, we could grab and parse these other ones. These are just the two that we're using right now. So once we've got our assertions written, all we get to do now is the fun part of running this. So there's a couple ways we can run it. One, if you've compiled this, you'll see a little block here that comes up with an arrow. You can simply click this arrow here. This will go ahead and run this individual unit test. This is going to fire up the simulator. The simulator is needed when we run the tests. And if all goes well, you'll get a nice green checkbox here. If we had multiple tests, or we had a whole suite here, say we had 5 or 10 tests in here, the other way to do it is to go Command U. That will run all the tests in the suite, and you'll get a nice output here also for the entire class. Now, just to get you in the game a little bit here, why don't we see if you can actually write 2 more assertions? See if you can grab the ID and description from weather and add 2 more assertions down here to just verify that we can indeed parse and read these from this incoming JSON. Go ahead, give that a try, and then we'll do it together after. Okay, good luck. Okay, so how did that go? Hopefully it wasn't too bad. Getting the ID and the description is going to be very similar to these assertions that we wrote for the temperature and the city name. First, we're just going to change our expected values. Instead of a temperature of 10.58, we're going to expect an ID of 804. And if we remember where that comes from, let's open up the weather data file. I'm going to do that showing you a different way of opening a file. Let's go Shift Command O. Look for our weather data object here, hit enter, and that'll just take us there. And there we can see that the weather is actually an array of weathers. There could be multiple weathers coming at us. That's just the way this API is written. If I go Command, Control, Command back arrow, I can go back here. So in order to get this ID, I first need to grab it from this array and then grab the ID. And for now, because this is unit test, this is okay. I'm just going to grab the first element and assume that there's a weather object in there. So I'm just going to go weather data.weather, I'm going to grab the first element and then grab the ID. Likewise, to detect that our description is for overcast clouds, let's come down here and just change our expectation to be overcast clouds. We'll do the same thing. We'll come in here and grab the weather. We'll grab the first element. Of course, here it won't be the name. It'll be description. And if we run that, I'm going to go Command U. Hopefully, we will see that we get a green arrow there. And voila, our unit test passed. That's great. So we've got great confidence now that we're able to parse JSON. We've got an example of how to do it in the happy path scenario. Let's see if you can write a test for the not so happy path scenario. We just got news that sometimes this city name won't come back to us. It can be blank. And it would be nice if we had a unit test to verify that we can handle a blank city name. See if you can write a brand new unit test to handle the case where city name is blank. I'm going to just leave it at that. I'm going to let you think about this for a little bit and just work through what you need to figure out and what you need to do in order to write a test that verifies we can handle blank city names. Okay, good luck. Go ahead and give this one a try and we'll do it together after. Okay, how did that go? I was purposely a little bit vague because I wanted you to go through the motions of figuring out how to write a brand new unit test on your own before we do it together. Because when you're on professional projects, you're going to be asked to write your own unit tests. I want you to start thinking about how we name and organize these things. But let's start by doing the simplest thing we can. Let's just take our entire unit test that we have here for the happy path, and let's just copy it down here and modify it for what we need. So in our case, we're going to modify the test data, the JSON itself. We know we need to handle this scenario. This is what we want to test, an empty city name, which means our assertion down here is obviously going to have to change. It won't be Calgary anymore. It'll be blank. And we should also give this probably a little bit more of a descriptive name to explain what it is that's unique about this test. So before, our happy path name was test can parse weather, but why don't we add a little bit more to it here? Test can parse weather with empty city name. So that's the variation. Everything else is the same. And I probably don't need to test these things again because I know we can already read the data and read these other values from our happy path scenario. This is all we really want to test. So I'm going to remove those other assertions and just leave this one here. So with that, let's see if we can run this. Now you can see the little arrow that I would normally click on here doesn't appear. Sometimes you just need to do a build. In this case, I just went Command B to run it, and then that little option appears here. And if we run this now, voila, we'll see that we're able to handle that new test case. And this is exactly what we want to do with unit tests. Whenever we get variations or slight deviations from what we expect, we want to come in here, and if we've got any questions, just write a unit test for it. Now, JSON being JSON, I probably wouldn't have to write too many of these because a JSON payload is a pretty concrete contract. In other words, the backend team probably wouldn't change too many things like this. But if I did have questions about things that could come back as blank or null or as different values, don't hesitate to go ahead and write a unit test for it. It's really good to remove that ambiguity, and you've got the unit test to cover you. Now this is a great start. This is really good for just testing little snippets of JSON, verifying that we can decode them and using them as structs and objects in our apps. But you can imagine sometimes the JSON can get pretty big. For example, here's the JSON for the full-on Calgary weather. As you can see, there's more elements in there. And if we wanted to copy and paste that text into every test file and repeat, our classes would start to get really, really big. So one other neat trick or something that's convenient to do to help organize our JSON responses is actually add JSON as a file and then load those into our unit tests off disk. Let's take a look and see how to do that now. The first thing we need to do is to create a test directory for where we'd like to stick our JSON test fixture files. So let's go ahead and do that now. I'm just going to go Command O to bring up our Explorer over here. And let's go into our test section here and let's add a new group and let's call it fixtures. This is where we're going to stick our JSON test data. And what we need now is a file to stick that into. So let's go ahead and create a new file here. Let's go Command N. And up here in the filter, just type the word JSON, and you'll get this JSON file, which is almost exactly what we want. Not quite, but let's go ahead and use it. Let's click Next. Let's give it a name, something like weather. And let's get rid of the geo portion here. So it's just weather.json. And here's a really important point not to miss. Make sure when it comes to the targets, you select your test target here to basically say, make this file be a member of the target. We need that because we want to be able to load that off of disk. And the only way they can do that is that if it's compiled in as part of an asset here. So make sure you select target and then go ahead and click create. And it will just ask you if you want to use the extension .json, even though the standard extension is JSON. Yes, we'll use that JSON. And voila, we'll now have a JSON file that we can edit. So now we're free to grab our JSON in its entirety and plunk that into the file. So I'm going to grab everything here. Make sure you don't select any comments like this, as that's not legitimate JSON. We just want the JSON. I'm going to come in here, just copy and paste, replacing what we have in there. And now we've got a JSON file on disk that we'd like to read into our unit test. So let's go back to our Weatherly test, the one we've been working with. Let's add a new test case down here. Something like test can parse weather via JSON file. Just a name I picked just to show us how we can do this. And reading in a JSON fixture like this is really a two-step process. The first step is we need to get access and figure out what the path is under the hood to get to our JSON file here. And we can do that like this. This is using something called the bundle, which is basically Xcode's way of representing all the files bundled within this app. And we're going to search the path for the name of our file, weather, along with its type JSON. This is going to return a path string for us, which shows us where on disk this actually lives. Now we can take a look at the contents of that. If we want to print out this path like this, I'm just going to print it out with a couple of carriage returns. And if we run this now, in our debug output, we should see where on path it has found our weather JSON file, which if we look at the console like this, we can see that it did indeed print it out. And here's the full path on disk. It's going to be your name way down in Xcode derived data. That's where it compiled this asset, and that's where it's finding it on disk. So that's step one. Now that it's found this JSON file and we've got a path string to it, we want to take the contents of that file and convert it into a string, some JSON, something we can parse. So the next step is to do this. We're going to take that path that we were passed in, get the contents of the file using that path name, and then have that come back to us basically as a string, which we're just going to name JSON. So we've got the path, we've got our JSON, now we're able to decode it. And decoding it is exactly what we were doing before. We're just going to take our JSON string, convert it into some data, and then use our JSON decoder to decode it using our weather data self on the data and hopefully get back some values like this. So if we run this now, we'll see that we got some errors, and that's actually probably okay because it turns out that what was in our JSON file isn't 25.65. Instead, it's 10.73. So that's great. The unit tests are working. So we'll just go ahead and change this to 1073. And then we can also see that we're not actually going to Paris, unfortunately. We are here in Calgary, which is also very nice. But that way we can verify that we're reading from disk. And if we run this again, this is how we can create fixtures on disk, load them in, and then read them as part of our unit tests, which gets really, really handy if you're doing a lot of JSON parsing or your JSON responses are really big. This is a way you can read and load them in. Hey everyone, thank you for hanging out to the very end. This concludes our Weatherly app, and hopefully you've got some good tools now that you can use to go out there and build your own applications leveraging a lot of the stuff we did here. If you'd like to continue the journey, do consider checking out my new book, iOS Tutorial. This is a completely free book I'm offering online, and in there you'll find an actual physical write-up of the Weatherly app we just built. So this is something that I've created because I know some people like reading text instead of watching videos. It's just easier to parse and go through a book than video. So if this is something you're interested in, I'll leave a link to the book in the show notes. Do check it out and do give me some feedback. This is something I'm working on. I'm hoping to spread some more ideas through this book, and if it's helpful, I would love to hear about it. Well, thank you so much for coming, everyone. I know that's been a long journey, but hopefully you feel more empowered and you can do even greater things with iOS development. So do come back, do hit subscribe, do hang out, and we will see you next time. Okay, take care. We'll see you then. Bye-bye.